The next question is, what is the domain of the tangent curve? So what are the x values that the tangent curve could possibly be? Well, the x values or the domain are all real numbers, or like any value of x that it could possibly be, except, and then we write like a line right here, x cannot equal, let's see, x is undefined at 90 degrees, and 90 degrees is pi over 2. X is undefined at 270 degrees, which is 3 pi over 2. And then it's any increment, you know, of that. So, you know, the distance between pi over 2 and 3 pi over 2 is positive pi. So it's like we're adding on pi every single time. So it can't be pi over 2. It can't be 3 pi over 2. It can't be 5 pi over 2. It can't be 7 pi over 2. And that kind of, it just keeps on going and extending on like that. Okay, so here's just a little bit of a summary about the graph of tangent. And tangent has no amplitude, meaning there's no max, there's no min. It extends on towards infinity in both directions, so there's no technical amplitude. The period is pi because that's the amount of space that we need in order to see one full curve. The domain is x, such that x is not equal to pi over 2. And then it says not equal to pi over 2 plus n times pi. And that just means like any multiple of pi going on after that. So if this n was a 1, then 1 times pi is just pi. So pi plus pi over 2 is 3 pi over 2. If this was a 2, this would be 2 pi plus pi over 2, which is 5 pi over 2. And it keeps on going on like that. And the range is all real numbers. Okay, so this is the next homework assignment, whatever one is next in your book or on your list. So we're moving really, really quickly through all these assignments, which is fantastic because hopefully you can get in a lot of those assignments to me. Okie dokie. Cosecant function. So we're going to start talking about the reciprocal functions, which is cosecant, secant, and cotangent. And these are actually really cool. It kind of looks kind of cool to see these graphs. You will never be asked to graph these functions on your own, but you will be asked to recognize which one is which. And I'm going to show you what that means. Secant and cotangent look very cosecant and secant look very similar to each other. Tangent and cotangent look very similar to each other. So you're going to have to use your calculator and kind of just like play the matching game, match up which equation goes with what. Okay, so here's what I mean. Cosecant x is 1 over sine of x. So the cosecant function is undefined when the sine function is equal to 0. That makes sense because you can't have a 0 in the denominator of a fraction. Okay, so let's see. I think that Ms. Tompkins went through and drew out all of these. So let me see. She probably did 0, pi over 2. Actually, let me think. Sorry, I just don't have this out right in front of me. Maybe 0, 90, 180, 270, and 360. Because we know what all those values are by just looking at our unit circle. So let's see, sine of x when x is equal to 0. So sine of 0 degrees is 0. Sine of 90 degrees is 1. Sine of 180 degrees is 0. Sine of 270 degrees is negative 1. Sine of 360 is 0 again. Meaning that because cosecant is 1 over sine, you're pretty much taking all these values and doing 1 over 0 is undefined. 1 over 1 is 1. 1 over 0 is undefined. 1 over negative 1 is a negative 1, and 1 over 0 is undefined again. So, cosecant has a lot of vertical asymptotes. It has vertical asymptotes at x is equal to 0, 180, and 360. You don't really have to remember that. I'm going to show you how we draw this graph. So by graphing sine and cosecant on the same set of axes, you can see how the two graphs are related. And that's actually like completely true. Let me show you what I mean. So we're going to take this and we're going to just graph out what the normal sine curve looks like, and then I'm going to do cosecant on top of that. And I don't know why these lines are never aligned properly, but that's fine. Okay, so we're going to go between positive 1 and negative 1 down here. I'm going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this is actually pretty cool. You're going to see how these are related. And I'm not going to do the whole thing again where we go through and find the exact values for every 45 degrees for cosecant. I'm just going to pretty much show you what it looks like, and you're just going to have to trust me, because at this point we have a lot more things to worry about than you trusting me. So sine starts at 0, ends at 0, goes through 0 in the middle, it hits its maximum first, and then it hits its minimum second. Okay, so if I'm going to graph what that looks like, I'm actually getting a little bit better at these. Awesome. And that's y is equal to sine of x. Now, we just said that cosecant has vertical asymptotes at 0 degrees, right? Because that's when sine is equal to 0. At pi, because see, every time that sine crosses the x-axis, every time that 0, cosecant is going to be undefined. So that's where we're drawing these vertical asymptotes. Remember, we saw these exact same things when we were dealing with tangent. It means that the function is never ever going to touch those lines. They're just going to get really, really close to them, but never touch them, and just keep going on for infinity. So this is a really cool way to draw cosecant. All you have to do is draw sine, and then cosecant looks like this. And it's never going to touch that line, but it's going to get really close. It's going to touch right at that same point. So at pi over 2, cosecant is equal to positive 1, and then it goes back up again. And then over here, it's going to come really close to this vertical asymptote, touch at 3 pi over 2, and then go back down again. So isn't that kind of cool? That's what y is equal to cosecant of x looks like. It looks like, you know, when you see it in a bigger window, that's just like a bunch of u's up top and a bunch of u's down in the bottom, and I can show you what that looks like right now. If I come over here. Now, there's no button for me to push in order to graph cosecant. You know, we only have sine, cosine, tangent. So how am I going to graph cosecant? I am going to hit 1 divided by sine of x, and that will graph cosecant for me. And I'm just going to look at my window, and we should be good. Okay, graph. So it's just a bunch of u's, which I think is pretty cool. So you can see how the two u's that we drew, they were just right here and right here. We were just looking at this window right in this part in the first and fourth quadrants. So we just saw that u and that u. But you can see how it extends on in both directions. If I made my window bigger, you'd see a bunch of u's up top, which is kind of cool. Alright, so if you ever forget how to draw cosecant, just draw sine first and then draw the u's up on top and on bottom. Guess what? So you're going to be the exact same thing for the secant function. Secant is 1 over cosine. So guess what we're going to do? So the secant function is undefined when the cosine function is equal to 0. So let's go through that same thing again. We're going to check it 0, 90, 180, 270, 360. Okay, so cosine of 0 is equal to 1 because cosine is the x value. So I'm trying to think of the unit circle in my head right now. Cosine of 0 is 1. Cosine of 0 is 90. Cosine of 180 degrees is negative 1. 270 is 0. And 360 is positive 1. So it's going to be the exact same thing. Now I'm looking for secant, which is 1 over cosine. So 1 over 1 gives me 1. 1 over 0 is undefined. 1 over negative 1 is negative 1. 1 over 0 is undefined, and 1 over 1 is just a 1 again. Okay, so that's how you can get those values really, really quickly. And then so you can see that there's vertical asymptotes at 90 and 270 degrees. which makes sense because that's where cosine is equal to 0 at. So we're going to do the same thing again, except for she messed this up. It's supposed to say by graphing cosine and secant on the same set of axes, and you can see how the two graphs are related. Okay? So let me check to see how much time I have. 5 more minutes. That's completely enough time. So I'm going to do the same thing again. I'm going to go between positive 1 and negative 1. You know what? I don't know why. Whatever. Doesn't even matter. Pi over 2. Pi. Or 90, 180, 270, and 360. Okay. Let's graph what cosine looks like. Cosine starts at its maximum, ends at its max, hits its minimum right there in the middle, and goes through 0 in between that. Now, I haven't seen any of the pictures of cosine or sine that you've been drawing, so let me say it again. Your cosine graphs need to be kind of flat up at top, curved down, kind of flat on the bottom, then curve up. Flat at the top again. Okay, so that's what cosine of x looks like. Now let's go back through and draw out where our asymptotes are for this one. Asymptotes are wherever cosine is equal to 0. So right here at pi over 2 we have an asymptote, and at 3 pi over 2 we have another one. And guess what? Secant is going to act the exact same way. It's going to, if I was looking at the bigger picture, it would come down right here, touch at that point, and then go off and extend on right next to that asymptote. Down here, it would come up next to the asymptote, touch at that point, and then go back down again, and then it would look like this. So on a test, you will never be asked to graph this, but you will be asked to, play the matching game and look at these pictures. Now, what I want to indicate, what I want to point out for you, is if you look at the picture of secant versus cosecant, so I'm going to graph secant for you right now. Those two graphs look really, really, really identical, okay? I told you this from the beginning. They look almost identical. They both just have U's going on the top and the bottom. But the only thing that's different is where they are in the picture. So if you are matching pictures and the graphs that they're giving you are between 0 and 2 pi, then make your window on your calculator between 0 and 2 pi. Take a look at what it looks like. And the only difference between secant and cosecant is that secant, this graph right here, we only see half of a U right here. We only see half of a U right here, and then a full U on the bottom, and then another half. That's how you know. Those are the tiny little differences that you're going to have to use to match up those pictures. Okay? And the cotangent function is the last one that we're going to look at. And I'm going to stop this and then start a whole nother video for cotangent. Okay?